A very good afternoon to all of you. I, Akriti Kumari, on behalf of CII, would like to welcome everyone to the CII series of webinars on Industry 4.0 for India. The topic for today's session is Transition from PROFIBUS to PROFINET Network. The session is brought to you by our partner, Utthunga Technologies. I would now like to welcome our esteemed panelist for today's session, Mr. Nirmal Tony Joseph. Mr. Nirmal is the in-house PROFIBUS or PROFINET expert and PICC certified installer for PROFIBUS and PROFINET. He also specializes in test automation of desktop, mobile, web, and cloud applications. He has over 10 years of experience in test automation and communication protocols such as ISA 100, Wireless HART, PROFIBUS, and PROFINET. A very warm welcome to all the participants joining us today. So before we begin with the session, I would request the participants to post their questions in the Q&A section, which will be taken at the end by our panelists. The questions would be taken up by our panelists one by one. I would also request our panelists to kindly keep themselves on mute while not speaking. So without any further ado, let me hand over to Mr. Nirmal. Over to you, please.
Thank you, Akriti. Good evening, all of you. I welcome you all again for this webinar, and thank you for this opportunity that you are providing us today. In this session, we will be discussing about PROFINET networks in brief, and why is transition from PROFIBUS to PROFINET required, and also we will be providing you all with some understanding on PROFINET diagnostics. So we also have our partners, Indu-Sol from Germany. So Frank Lehmann from Germany will be walking us through this presentation as well. And yeah, so he'll be controlling the slides. Can we move to the next one, Frank? Okay. So a brief about Utthunga Technologies. So we are, our focus is in industrial automation and controls, power and utilities, building automation and controls, motion and mobility controls. We also have our service offerings towards digital engineering, production applications engineering, embedded services, security, verification, and validation as well. Next one, please. So Utthunga has been in the industrial automations market for 14 plus years now. We are 700 plus professionals currently, headquartered in Bangalore, and we have our offices in US, Germany, and Japan. We have 50 plus customers from the industry, and 100 plus, we have worked on 100 plus products. Our main services and contribution has been in fastening the releases by up to 40% and reducing vendor management systems. And we build a better industrial company with co-creation partnership. Next one, please. So some of the key industrial associations that we are part of: OPC Foundation, EdgeCross, EtherCAT, PICC, ODWA, FTT Group. So basically, we contribute in different ways. One is being part of these different special interest groups, being a technology outsourcing partners, and we also are part of global expert speakers community. We also have FTT Test and Certification Center, and we also have a compliance and certification centers for different industrial automation protocols. Next one, please. So to introduce about Frank Lehmann. Frank Lehmann is from Indu-Sol. He's the head of product management at Indu-Sol, an expert in PICC as well, and working at Indu-Sol for more than 13 years. And Akriti has introduced me. Next slide, please. So about Indu-Sol. Indu-Sol has been pioneering in different protocol diagnostic services. So they basically work on managing networks, localizing weak points, and ensuring system availability. They have multiple diagnostic tools and products for different industrial automation protocols. And they are partners for planning, installation, and operation and maintenance. Next slide. So to talk about PI, so PI is a group that controls PROFIBUS, PROFINET technologies. So it is like one stop for to understand complete information from PROFIBUS, PROFINET technologies. So they have been very they have facilitated migration of centralized to decentralized automation systems, automation technology, and information technology using Ethernet-based communication systems. And they are enabling continuous communication from field level up to corporate level management. So basically from field network to process networks. Next slide. PICC was formed in 1987 by members of the Central Association for Electrical Engineering in Germany. And since 1989, PROFIBUS has developed into world's leading field bus system for automation. And we have over 47 million devices installed or commissioned in the areas of industrial automation. A little brief on PROFINET itself. PROFINET complements the trusted PROFIBUS technology for applications that require fast data communication and in combination with industrial IT functions. So by 2013, we had around 7.6 million PROFINET devices installed in the market. We have crossed a 25-year mark in 2014. Next slide, please. So the PI, which is an umbrella organization for 24 RPAs, we call it as Regional PROFIBUS Associations, and we have spread across the world with, like I said, 24 RPAs and 56 PICC centers, 31 training centers, and over 9 test labs. So the objectives of PI itself is in promoting worldwide dissemination of PROFIBUS and PROFINET technologies, sales and promotions of these technologies, securing quality standards through test labs and certification of devices, coordinating international cooperation of regional PROFIBUS and PROFINET organizations. Next slide, please. A little about PROFINET. Next slide, please. So PROFINET itself is one of the industrial Ethernet standard protocols in the market. PROFINET has been growing pretty fast and having a larger footprint year on year. So it is around 24% since last. The PROFINET number of installations for PROFINET has increased by 22% compared to last year. And last year alone, it was around 7.3 million products placed installed in the market in 2020. This is the same amount of devices that were installed up till 2013. So it's actually like whatever was achieved till 2013, we have achieved that within a year's time in 2020. Next slide, please. So this is a brief about PROFINET, and Frank will walk us through the rest of the presentation. Over to you, Frank.
No. So thank you, Nirmal. Yeah, I'm Frank from Indu-Sol, and I want to show you or share with you some information about PROFIBUS and then also the new technology PROFINET networks. So at first we want to look, okay, what is Profibus and what is PROFINET? Therefore, we have some slides that we have to look, okay, what is the topology maybe, and what is also the communication in this network. At first point, we have our Profibus system. For the Profibus system, we use a wire or a cable with 2 wires, and we have the possibility to send or receive informations from the network. Basically, we have 1 master in our network and some slaves. And the cyclic communication is based on a master-slave communication. The master sends some requests in the network, and the slaves have to respond the message back to the master. And yeah, topology information, we can have up to 32 devices per segment. For example, if I need more devices or I need a longer line length, then I have to use repeaters. This repeater, yeah, the name is repeater. They repeat the frame inside the other segment and so on. And I have also to set a termination at the end on the starting point of each segment. This is the communication in the Profibus network and also the topology in the Profibus network. Yeah, for example, this is a basic network structure. I have 1 PLC and I have some devices, and the basic structure is a line structure. This is Profibus. Now go to the PROFINET communication. So the first difference is in this part of network type that we have 1 cable with 4 wires. Therefore, we have the possibility to send and receive to the same time informations to the network and receive informations from the network. This is the biggest benefit from Ethernet-based networks with the application PROFINET. The other point is I don't have repeaters in my network. I have switches, and the switches have a higher intelligence inside than our repeaters. And the other benefit is that I don't have a physical line structure through my whole devices. I only have a physical line structure from 1 device to another device. So I have an end-to-end communication between 2 devices, and termination, what I have to put on or turn on in the Profibus network, I've integrated in each device. So I don't have to turn on or turn off my resistors in my network. This is a little benefit, I think. In the first point, when we go deeper, then we want to see, okay, what is the biggest benefit from this if I have line error and so on. And the other case is I don't have a master-slave communication in my PROFINET network. I have a real-time communication based on update times. That means the controller have to send some information to the device with their own update time, maybe 1 millisecond or 2 milliseconds, and to the same time, the device have also to send in the same update time information from the device to the PLC. It's not a request and a response, it's only send information. That I have in real-time communication. So this is at the first point some difference between both worlds, Profibus and PROFINET. And for example, in this case, I have my PLC, then I have a switch maybe, and different daisy chain or line structures for my I/O communication, or my I/O devices are connected in a line. And what is also different, I'm with PROFINET on an Ethernet-based world, and therefore I can also add other devices to my network, for example, an HMI, that the HMI can use the network with their own application. If they don't support it PROFINET, they can also use acyclic communication with my PLC or with other devices. So this is the different. PROFINET, 1 network, 1 application. PROFINET, 1 network, more than 1 application. For example, PROFINET or other types of applications. So now go to our Profibus communication again. And now I have, for example, a physical error in my network. Therefore, maybe I have a line broken, or I have an aging in my line, and I have some impact to my communication because my line quality is not so good. And therefore, in Profibus world, it's really hard to localize this cable problem, because I have one line and the line is terminated on both ends of the network. And if I have a line or physical error, then the whole communication is interrupted. And sometimes maybe our customers or the Profibus guys use diagnostic repeaters to detect such line problems or to monitoring the line. And yeah, it's really hard to find without these tools. Now we go to the PROFINET world. So we have learned, okay, there's a line structure between the single devices, and the termination is inside the devices. And therefore, if I have a physical error in a line, then I don't interrupt the whole communication in my network. Only the communication with the devices behind this line are interrupted, because I have physical lines or separated physical lines in my Ethernet-based network. So I think this is a big benefit if I use PROFINET or Ethernet-based networks, that on the physical side, I can find really quickly bad cables or bad connections. Now, start with the topic tips and tricks for planning and acceptance of my PROFINET network. So maybe we have some parameters or information what we can use to make the first planning, that we have an information that the network what I want to install is fine and have a higher availability for my machine, that my machine can work without any stops or shutdowns. And therefore, if we look to the PI, we can find some guidelines for design, for installing, and also for the acceptance. So then we can start with our planning parameters. This is not only used for PROFINET, you can also use this for Ethernet-based networks. Then we start with our net load. The net load is the utilization of my network, or the used bandwidth from my application from the network. For example, my PROFINET network can support me in transmission speed of 100 Mbits per second. And from this 100 Mbits, I should use up to 20% or up to 20 Mbits per second from this provided bandwidth. Then we have also the parameter update rate. Update rate, we have learned about this in our PROFINET communication. Each device have their own update rate. You have to configure this in your engineering tool like the tier portal, and you can set for the different devices different update rates. And yeah, the update rate means the interval of the sending of frames from the PLC to the device and from the device to the PLC. This is a part. Then also line depth is an important parameter. The line depth describes, okay, how many hops or the numbers between my PLC and the I/O device, the last I/O device. It can be 7 hops or 8 hops. If we look in the PI guidelines, then we find a little table and can look, okay, is my planning passed to my line depth. And also access points of network or for network diagnosis is a part that I have the possibility to get an access to the network when the machine is running. I don't want to stop the machine if I want to monitor or if I want to make a service in my machine. Therefore, I have to plan also an access point to get a communication from the network, and also a service port or an access port on the switch that I can put it or connect it my laptop to the network and can make some services or maintenance work. And at least my network structure and the components in my network. Yeah, in PROFINET, the PI described the different devices with different functionalities, and I can choose, okay, I need this functionality, I need this functionality, and then I can use these devices. Or my requirement for the network, I have to use a star structure. It's really easy to handle, and so on. So this is some planning parameters for PROFINET typical devices. If I go deeper to the different parameter, this is the net load. This is a slide from the guideline. That means, okay, if the net load, what I want to plan or have to plan, is lower than 20%, then everything is fine. And I can use this planning for my installation team or for my engineering team. If the net load is between 20 and 50%, I have to look again, okay, is the net load what I calculate with my planning, is this the real net load, or I have the possibility to change something that I get a lower net load? Then I have to do this. And if the net load is higher than 50%, I have to do something to reduce my net load. Yeah, and if I look to my update rate, this is an example that I have, a graph with the number of nodes. And if I have more nodes with the same update rate, my net load will increase over the number of nodes. And for example, if we look to the point 50 devices, if 50 devices send information with an update time of 2 milliseconds, I have around 20 or a little bit higher than 20% net load. That means, okay, I have the possibility. I can go back to my planning. Maybe I have to choose 4 milliseconds for my application, and therefore I reduce the net load from 20% back to 10%. And I'm really happy because I'm lower than 20%. Yeah, the next one, the parameter line depth. So they describe the number of devices between the PLC and the last I/O devices, or the number of switches. And that can be the basic infrastructure switch, or can also be the I/O devices with 2 ports. There's also a switch included. So then I have to look to my planning. I have to select the devices, and I know, okay, in this case, maybe I have a line depth of 9. And if I look also in the guidelines, then I find the maximum line depth for the different update times. And if I use an update time of 1 millisecond, then I can use a line depth up to 7. Or if I use an update time of 2 milliseconds, then I can use a line depth up to 30. This is the parameter line depth. And now, what is the solution? I don't want to draw for my own in a page. Maybe there's a device, and I have to calculate something. No, the basic or the best solution is a little software that is a little helper for me. I can draw my topology, and I get automatically an information for the different parameters what we can describe. I can describe net load, I can describe the line depth, I can describe also some important information that I can select my switches for my network. That on one hand, maybe I can save money because the switch don't need highest performance, that I can choose a lower performance switch, or I can save availability of my network, that I chose the correct performance switch and not a low performance switch. I need a higher performance switch, that the switch can handle the whole net load in my network. Therefore, we can describe backplane capacity, you can describe the throughput from the switches, that you have a parameter to select also switches for your network. And at the end, network access, and also we can describe the availability of the network. This is a solution, it's an easy tool to use, and it's called PROFINET Plan. Yeah, now we are finished with our planning. We give our planning to our engineer or also to our installation team to grow up my machine or my plant. And then, yeah, maybe I have to make an acceptance test of the network, or I want to check that the engineer and the installation team have to do their work and they use my plant parameter. And therefore, I can also describe some parameter. On one hand, how good is my communication, my PROFINET communication, or how stable is my PROFINET communication. And on the first step, I want to talk about the update rate. So I set an update rate, maybe 2 milliseconds. This is what the engineer have to configure in the PLC. And then it's really important to know, is this configured time the real update time? And therefore, I can describe the difference between the real update time, so what is the real communication or inside the real communication, and the configured update time. This parameter is called jitter. And if the jitter is higher, then the difference between my configured update time and my real update time is higher. And yeah, and if I look again in the PI guidelines, then I want to find, okay, there's a threshold around 50%. And if the jitter is lower than 50%, the communication have an, or is a stable communication. Then the next one, the telegram gap. So it's also in the near of the update time, so you can make your own understanding. Each package in the PROFINET application have a number. The first package of number 1, the second package after number 2, and the third package number 3. And if we receive package number 1 with 1, 2, and 3, then everything is fine. But if the package number 2 is lost, then we can describe this issue as a telegram gap. It's not a difference between our update time. It's a real gap in the communication. The next one, the telegram error, it's nearly the same, that I receive package number 2, but package number 2 is destroyed and I don't understand the information inside this package. This is an error frame or a telegram error. The next one, the load radio, it means, okay, if I want to use PROFINET, then I want to use a real-time communication. And therefore, the most frames in this network should be PROFINET, or the most frames from this PLC to the network should be PROFINET. And this I can describe with the load radio. So it's the load radio between PROFINET telegrams and all other types of telegrams. And it means the load radio should be higher than 100 to 1, more than 100 PROFINET packages to another type of package. And then the last one, again, our net load. That means, okay, on the one hand, I plan my net load and I want to check also the net load with an acceptance test. So this my parameters. Now the question again, what is the solution to describe or to analyze this parameter? The solution is very easy. I need only one tool, and this tool I don't have to configure. This tool make an automatically analysis about the whole communication between my PLC and my PROFINET network. That means, okay, I can connect this device to my network. This device make an analysis over the whole communication and describe all parameters for each device. And after them, I get a result. Okay, if everything is fine, then I have a traffic light with green for all devices. Or if there is something in the communication, then maybe the communication is not stable, but it's the machine is working. Then I get a traffic light maybe with the coloring yellow. And then I have the first information, okay, there's something, and I have to do something. Yeah, this is the one hand of the communication quality, or of the quality what I can check after my installation. And on the other hand, I can also look deeper to my topology or deeper to my devices. Therefore, there are also some interesting parameters. We start with Netload again. So maybe other devices, not PROFINET devices, are also connected to my network, maybe an HMI or a PZ, or yeah, a camera system and so on. And these devices make also additional net load in the different parts or installation parts of my network. And therefore, I can describe maybe in each line of my network the parameter net load. Then the parameter, the next one, the discards. So it's a parameter from the Ethernet-based world. And it means, okay, if a package is dropped because the performance or the resources inside a device, it's not enough, then we call it discard. You can make an understanding. We have a little warehouse inside the switch, and we can receive some packages. And if the warehouse is full, we don't have any place to store more packages, then we have to drop this package, and we want to call this as a discard. And nearly the same in the switch. We have a memory. This is our warehouse, and we don't. If we can store more telegrams in this memory, then we have to drop the new packages, and we want to call this discards. The next one is the errors. Also, not only the net load, not only the discards we can check in a network. We can also check. Okay, have the switch or the device receive a package and the package was error-free, or was the package destroyed? And if the package is destroyed and nobody knows the information inside this package, then we call it as an error frame. The next one, again, our planning parameter line depth. I can also scan, or if I look to my final topology, then I can also again check the real line depth. And at the end, asset management. This is the device view that I have the information. Okay, what IP settings are configured or installed, what devices with which software version, with which hardware version, that I have more information about my devices inside my network. This is the part of the asset management. And what is the solution again? The solution is not to look or go to the different devices, look the installation line. Okay, maybe on port 1, it goes to port 2 of the other device and so on. No, the easy solution is that I have an access point in my network, and I can use a software like ProScan Active to make a scan from my network, or maybe I can use also the PROFINET inspector, so the same tool to describe the communication quality in my network, to scan my network, and the result of this scan is, in the first step, I have a topology overview. Topology overview means I know the correctly or the real installation of my network. That I find, okay, there's a switch, and on this switch on port 2 is connected this device. And no, I don't have to open the switch cabinet, and maybe the port 2 is connected with this device, but nobody knows correctly. Only with this solution, I have a real topology of the current installation of my network. And also, I have the completely device list with all informations from my devices. And at the end, again, my diagnostic informations that I know, okay, in the different lines, I have maybe a lower net load or a higher net load, or in different parts of the network, I have errors. And then if I detect errors in the network, I have the first information, maybe there's something with the line. and maybe I have to check the line, or I have to exchange the line, that I have a more stable communication in my network. Yeah, this is the part of the network planning and also the part of the acceptance test of a network, or to measure something. Yeah, that I plan in the first, and after them I can check with some tools also the installation and the configuration of the network, if it's really the same like the planned configuration, or is there's different and I have to change again something. Yeah, now we come to the special features of PROFINET network infrastructure components. So we have learned about, yeah, there are some switches. Switches have a higher intelligent inside, but now I want to show you again what is a switch. A switch, yeah, have some intelligence inside. They have a memory inside, and they have also an address table. And that means if the switch receive a package, they look inside the package. Okay, what is the destination address? They look in the address table, and if to this destination address the port number 2 is selected or is added, then only the switch send out this package on port 2. And if we look in our PROFINET application or network, then the PLC on one hand sends some information to the network or to the devices, and the switch receive on port 1 all information, all packages, and they look inside the package and send out on the destination port who is connected the single I/O device. So this is the basic work of a switch. Now we are in the real-time communication PROFINET, and therefore a switch have to do also other work. First step, what I can describe, what a switch can do, or what a PROFINET device can do, because a PROFINET device have also included a little switch, is that the PI describe different conformance classes. Different conformance classes means I have a class 1, class A, class B, class C, and for example, class B included also the features from class A and so on. And if I look in the real installation, then with class B, I can cover 99% of the features what I need in the different networks. And therefore, if I go also in the class B, I find the information, okay, I can provide, for example, topology scans, I can provide some diagnostic information or device diagnostic information. I can provide also, yeah, a cyclic and acyclic communication. And what I have also, I have certified devices from a PI test lab, for example. And class Z, if I want to use this, I have to use this for the IoT communication or the isochronous real-time communication for the motion control. So it's not often used, but sometimes it's used, and therefore I need conformance class Z devices. And basically for I/O communication, I can use conformance class B devices. And the next one, yeah, if I want to use real-time communication, then maybe it's good that I have a prioritization from my real-time communication. And it looks like this. If an ambulance and a car come to a road crossing, then everybody know, okay, the ambulance have a higher prioritization. And this is also what the switches do. If they detect there's a PROFINET frame, then they send out at first to the PLC. And if a camera frame comes to the switch, then it's the second frame what it's go to the PLC. So that's called quality of service. Yeah, and then the last one, important feature or parameter what I can use is the Netload Class. This is also and test in the certification of the devices. The vendor can use Netload Class 1 or 2 or 3 for the certification. And this is also what you can find in the PI product catalog. You can select, okay, I want to use switches with Netload Class 3 because they have a higher robustness for the net load inside my network, and therefore I have a higher availability of my network or stable communication in my network. And yeah, so higher the classes, so higher are also the robustness of the devices through the network traffic. Yeah, and now to my last part in this webinar, that we also, yeah, maybe there is something what we can also measure, or maybe we have new measure technologies and so on, and what is the procedure behind this. And therefore, yeah, we are a company to describe how good is the quality in the network, that we provide some more information to describe the quality, and we have also some service guys. And these service guys make around 600 measurements each year by our customers. And this is a good information also for me and also for our development department to find what is the typical failure in the industrial environment or in industrial networks. Therefore, we provide each year our Vortex analysis, and this is an overview of all our measurements. And there's also in part included the typical failures inside a communication network. And if we look maybe in the year 2020, or the result of the year 2020, we find a big part. This is the yellow, this is the red one, the purple one, and the blue one. This is cabling, this is plugs, and the line length. So this is the biggest typical failure inside our networks. And maybe if I have the possibility to describe this parameter or describe the quality of my plugs or my cables, then maybe I can solve some blend stops before the failure or before the blend is stopped, and I can make my maintenance work, for example. The next one is the performance one. And if I look in the year 2017 up to the year 2020, then I can see, okay, there's an increase in this parameter. It's come from 50% up to 32%. And this, if I look deeper also in the performance parameter, then I have the information, okay, there is something with jitter, there's something with net load. And this is an indicator for us that more guys use PROFINET, but they don't make an, or they don't have enough knowledge to make a planning or to use PROFINET correctly, because they come from maybe also from the field bus system, PROFIBUS, and in this system we have other parameters, or we make an other planning for my PROFIBUS system, and they don't use a Ethernet-based planning. But if I use Ethernet-based planning, then I can select the correct switches, and I can make also a net load or bandwidth planning. And if I use this both topics, then maybe I can solve also this issue. Or maybe I have to monitor the performance, that I can find some indicators that I have to change something maybe. And the last part, or the third biggest part, is the EMC topic. So that maybe I have some frequency converter inside my network or inside my installation, and through this motor cabling, I have an impact to my data lines. This impact is a high current on my shield, for example. Through this current, maybe I destroy some devices, or I destroy the communication in my line. So these are three big topics in our daily work or our daily service work. And now the question is what we can find, or how we can find this or solve this issue before the issues occur. The first topic is the cables and the plugs, and therefore we can make a measurement over the whole time when the network is running with an online cable diagnosis. So that means, okay, the switch can detect the line length of the cabling, they can detect the signal voltage inside the cabling and so on, and can describe with all little parameters how good is the cabling. And if the cabling don't have the highest quality, then I have the first information, okay, maybe there's an installation fault. After my installation, I can also use this as an acceptance test, or over the time, I have an aging in my cabling and the quality goes down, down, down. And maybe if I don't look to this parameter, or I don't look to the quality of my cable, then I come in the area of the breakdown or of a communication breakdown on this line. And with this communication breakdown, I have a blend stop. And therefore, you have the possibility to describe this parameter. And if I have a lower quality, I can do something, or I can plan my maintenance work. The next one, the performance one, is again our net load that I can detect also in infrastructure components like a switch. On each port, how high is the net load, how high is the discards counter. So sometimes maybe I have a little peak in my net load, and therefore to this time my warehouse inside the switch is full and I can store some packages, and I have discards counter on these different ports and also the error counter. And yeah, the benefits is that I can check this after my installation, and I make look again to my planning. It's the same, then it's good. And if it's not the same, maybe I can change something in the configuration to get a lower net load. Yeah, and the last one, the EMC measurement. Again, we have our shielding current, and we have also, or can provide an infrastructure component like a switch with a leakage current measurement or with a shielding current measurement. And therefore, I have the information after my installation or after my first start of my plant, how high is the shielding current. If it's in a green area, then I'm happy. I have a good installation. I don't have to measure something in my network. And also over the whole plant life cycle, I have the information, okay, it's really stable, or I have a change inside my leakage current, and then I have to do something. But I have the first information, and I can use this information or use this important information. Yeah, and at the end, the measurement technology of switches, line quality values, discards, errors, net load, and shielding current. These all parameters, what I can describe with basic infrastructure components, and I don't have to use additional tools that I have to go to the network. I can make an access to the switch, I can look to the web page, and I get informations from these switches for this installation place. If you want, you can try it for your own. We have a little demo inside or you can connect it with the World Wide Web, p10demo.indu-sol.com, and you can look or you can test something. Yeah, at the end, steps become a PROFINET expert. So the really important topic is to start with a network planning. With the network planning, you have the first information that you have information about your network, and you don't have to installing, and after then maybe the LED of the PLC goes in the green state or it's in the red state. For this, with network planning, you have the first information, and you have also some documents or sheets for installation team and for your engineering team. Yeah, use the correct switches or infrastructure components for your network, use certified devices, use high performance devices if you need this in the network planning. Yeah, then yeah, basic infrastructure can also provide you additional monitoring and analysis about the network over the life cycle of the plant, and yeah, make an acceptance if you need it after the installation. So therefore, I'm finished from my side, and I will hand over back to Nirmal. Thank you.
Thank you, Frank. I have a case study for you to be presented to you today. Basically, this is one of the sites warehouse divisions that we visited as a service for PROFINET, resolving PROFINET issue in this particular warehouse division. So our client had dynamic drives which control overall conveyors, which automatically distributes the products to different delivery vehicles. Now, what they used to face was a frequent intermittent PROFINET communication issues that used to halt their production and actually lose time and used to get delayed with the deliveries. Now, Utthunga, along with Indu-Sol, we had inspected this site, and we did provide the network solutions, diagnostic solutions, using some of the tools readily available from Indu-Sol. One of the major or main tools that was used during this study and analysis of the PROFINET network is the PROFINET Inspector. This is a permanent monitoring tool that can be installed on your main panels against beside your PLCs, and a brief network connection is shown in the picture. But where your controller communicates, controller communication is monitored with this PROFINET Inspector. Now, can you move to the next slide? Okay. There should be a slide before Frank, I'm sorry. Yeah, so basically, if you see the diagnostic procedure, as a first step, we installed the PROFINET Inspector and then monitored the network for over 12 hours during production. During this 12 hours, we got enough of relevant data from which we could understand what the issues were. And we also used software called as ProScan Active software. This is used to scan the topologies, and also ProLine test cable measurement tool. Now, the issues when we identified were primarily there was a lot of jitter issues that was happening, and a lot of Ethernet packets that were moving around in the PROFINET network, which used to take basically your net load was above the recommended standards, and the switches that were used were not managed switches. Now, all these three things that has to be noted during any commissioning of the plant, and that ensures having a better and a stable network is very much required is a very important step to be considered. Once we had identified these issues and we have provided recommendations to our client, and then the results were good. We had now completed a PROFINET network audit, and then we did show the client what the problematic area was and where we had to do certain improvements. And this resulted in improved operation efficiency, and as well as guaranteed high availability of the plant with continuous production. Just to brief on the architecture itself, there were delays or jitters based on your line depth. Frank has already spoken about this. Just to reiterate, based on your update rate in your network, you need to ensure that your line depth is under control, and as well as any devices or infrastructural components that add on to your network net load needs to be checked and considered even before you really introduce them into your PROFINET network. So as a final slide to show certain recommendations, Frank, can you move to the next slide, please? Yeah. So generally having an audit post-commissioning of the network would be beneficial, and this will become the baseline for the network parameters and performance parameters in your plant. Based on this reference, you could have periodic audits and to ensure that these network performance parameters are monitored and compared against the baseline parameters. And if you find any degradations in performance, this can call for early maintenance, and that way reduce your plant downtime. Certain performance parameters which you really need to concentrate on, or what needs to be in your audit documents, should be that if there are any failures or restarts in the network, are there any unwanted alerts that are getting created? Is there any excess jitter in your network, frame gaps, or consecutive frame gaps, frame overtakes or error frames, load ratio, a maximum net load, and maximum payload or the line depth. Now, these are parameters. There are some thresholds that can be the threshold values shown here is our recommendations, and if these recommendations can also be made stringent during your audit and ensure that you have a quality and highly reliable network. So this comes to the conclusion of our webinar. We would encourage for any questions from you. Thank you.
Thank you, Nirmal. Thank you, Frank. We have some questions. We are running out of time. We'll just take it quickly. So we have a question from Mr. Manas Mohan Rana. He's asking that for sure, PROFINET is very ideal for industrial network. Can it be used for railway applications?
Yeah, also from my point of view, you can use also for railway applications. So in Germany, we use this also in some kind of these applications.
Thanks, Frank. We have next question from Mr. Karthikeyan. He's asking that failure analysis. Can you elaborate more on the performance? 32% in 2020. So I think you would have shown something in the slides.
Can you repeat failure analysis?
He has written that failure analysis. Can you elaborate more on the performance? That is 32% in 2020.
Okay, so this is from the Vortex report, Frank. So in 2020, you have said performance contributed 32%. So can
the performance, we have 32% last year. And therefore, we can see that topic Industrial 4.0 or digitalization, that we have more and more communication inside our UT networks, and therefore we planned with the same devices or with same switches from the year 2010 or 2015, but now we have more communication inside our network, and therefore we have also to choose other kind of switches and not only basic unmanaged switches or basic managed switches. We have to choose really good switches for the whole communication, that we have a good performance inside our network for all applications.
So just to add on, currently the demand with existing plants is that as we upgrade our plants to ensure additional devices and we have speedier access to the network, performance is one thing that comes into question very much, because the requirement is, like as Frank mentioned, is demanding as well. So some of the issues that are coming or failures that we generally see is because of performance. And for performance, if you see the plant itself might have been set up, say 5 to 10 years ago or 15 years ago, and you constantly upgrade the plant, but sometimes we ignore on the infrastructural aspect to have baselining these performance parameters. Now, when you actually upgrade a plant, you need to ensure that having adequate infrastructure and ensure that the performance is to the baseline mark. Okay, if this is not done, yes, we do have failures coming with performance. I hope that answers your question.
Yeah, thanks, Nirmal. We will take the last question. This is from Mr. Siddharth Joshi. He's asking that how to control leakage current in PROFINET cables.
Yeah, one way is to have a big distance between our cable for the communication, so our PROFINET cabling, and for example, the motor cabling with a big impact to our cable. Use symmetric motor cable that the impact is not so high, and also that you have an use a good bonding network system, that you use a mesh BN, that the whole the current don't flow through our shielding or around our shielding of the data lines, that the current has to flow over the bonding network system. Therefore, if you have some or need some information, you can find also on our webpage the MCLOT system, that you can provide also your machine or your plant with a good bonding network system, that the leakage current is not a problem for you.
Thank you, Frank. So as this was the last question, I would like to now thank to all our panelists, Mr. Frank and Mr. Nirmal, for such an insightful session. And I would also like to thank our participants for joining us today and making this session a success. So we look forward to having your feedbacks, please. Thank you, everyone.
Thanks all.
Thank you, too.
Suggestion.